important concept to copy down is how to find the altitude. So in this case, we are looking at a perpendicular slope, so a line that's going to bisect AB at 90-degree angle. So it would help to draw a diagram. So if I had the triangle AB, now this doesn't have to involve the midpoint at all. See, I have this other vertex C. However, my altitude has to go through my vertex C and has to bisect AB at a 90-degree angle. That is the altitude. Get rid of this. So when you're trying to find the altitude, you have to substitute your vertex as well as the perpendicular of slope of AB. Okay, so tune into part 2 of the seminar where we go through more elaborate examples and start off with the intersection point of your altitudes, medians, and perpendicular bisectors. Okay, this is part 2 of our seminar. We're going to start off with a few definitions. The circumcenter, first of all, which is our main seminar activity, is going to be based on the circumcenter, and that is the intersection point of all 3 perpendicular bisectors. Now the centroid is the intersection point of all 3 medians in a triangle. The orthocenter is the intersection point of all 3 altitudes. Okay, those are going to be very important, and the majority of your marks on your assignment are going to be based on the circumcenter, centroid, and orthocenter of a triangle. Let's just see what these concepts actually look like. Okay, so in this diagram, the circumcenter, if I'm considering triangle A, B, C, and I look at my chord AB, this is going to be my original perpendicular bisector. You notice that it intersects at a 90-degree angle. If I look at side AC, I can see another perpendicular bisector. And if you look at line BC, there's another perpendicular bisector. And you can get 3 different equations. However, they all share a common intersection point. If I'm looking at but instead of doing all 3, I think it's enough. We've already got used to the right bisector, so we are going to find the circumcenter now, the intersection point of the 3, and we're going to actually choose 2 perpendicular bisectors. So consider the triangle with point A, 5, 1, B is going to be -2, 0, and the vertex C is going to be 4, 8. Now, first of all, we're going to come up with the perpendicular, or right, bisector equation for, or of, AB. So I'm only looking at my points A and B right now. Okay, so I'm going to follow the steps that you wrote down before. First step, step number 1, is to find the midpoint of AB, which is equal to 5 plus -2 divided by 2, and 1 plus 0 divided by 2. That's going to give me the midpoint 3/2, 1/2. So I'm using fractions for a reason. I want you to practice using fractions. Step 2, find the slope of AB. So taking my y2, 0, subtract my y1, over x2 minus x1. That's going to give me negative 1 over 7, or positive 1 over 7. The perpendicular bisector slope of AB is going to be the negative reciprocal of that. So negative 7 over 1. So now we have 3 pieces of information that we can use to find the equation of the perpendicular bisector. So I'm going to use my point, 3 over 2 1/2, as well as my perpendicular slope, which is equal to negative 7. I'm going to plug it into my y minus y point is equal to slope x minus x point. So I'm going to substitute values into y, x, and my slope. So y minus 1/2 is equal to negative 7 times x minus 3 over 2. To use the distributive property, y minus 1/2 is equal to negative 7x plus 21 over 2. Move everything over to one side and isolate the y. Y is equal to negative 7x plus 21 over 2 plus 1/2. Y is equal to negative 7x plus 22 over 2, which just simplifies to y is equal to negative 7x plus 11. This is my equation number 1, and it's my right bisector of AB. Now, in order to find the circumcenter and the intersection point, I need to now find the right bisector of BC using the point B and point C. So my point B is negative 2, 0. Point C is 4, 8. Now we're going to repeat the exact same steps. However, just to save some time, I'm just going to give you your final answer, the final equation of the line. So if we repeat all of the steps we did for part A, you're going to get negative 3 over 4x plus 19 over 4. That's an equation with a lot of fractions. And this is my right bisector of BC.